Number 12 here is the last of the four problems they asked on 9 through 12, all dealing with this sliding ladder problem, where a ladder is on the ground leaning up against the house, but the base of the ladder is sliding out away from the base of the house or the wall. So what's happening here is that X is increasing in time. H, on the other hand, though, is decreasing as the top of the ladder is actually sliding down the wall. So 12 asks an interesting question. What is the relation between H and X at the moment when the top and bottom of the ladder move at the same speed? Okay, so what we're looking for, they didn't really give you a derivative right here, but we kind of want to know what's happening here when dx dt, all right, when dx dt and dh dt are actually equal to each other. Now, I should be careful. They're never really going to be equal to each other because dx dt is going to be positive since x is growing. dh dt is going to be negative since h is shrinking. So really, if we put an absolute value here around the dh dt, that accommodates for the idea that we're talking about speed and not velocity. Okay, let's deal with this problem the way we have been. The Pythagorean theorem is still the relationship that ties together h and x. So this would be something like x squared plus h squared is equal to your hypotenuse, 5 squared, which is 25. So that's the same relationship I believe we used on 9, 10, and 11. Now we're using it here again on 12. And then here, if we take the derivative of everything, we're going to get a 2x times a dx dt plus a 2h times a dh dt, and that is going to equal 0 here, the derivative of that 25. Now, in most problems, they gave you one of these values right here and asked you to figure out something else. But what's going on in this case right here, guys, is they're telling us that dx dt and dh dt are going to have the same, at least in terms of the same absolute value. So what I'm going to do here, guys, is, let's think about that, basically that they're going to be the same with one another. So basically then, trying to think of the best way to explain this algebraically, these two quantities are basically going to kind of become null and void right here because they're essentially the same. So what I'm thinking here is I'm going to say, all right, 2x and then a dx dt is going to equal a 2h and then a dh dt. Now, that probably should be a negative right there if I'm just solving that equation. But again, with the absolute value issue right here, that negative really doesn't become important. Really doesn't matter that much, and I can kind of ignore that. Really, the reason why is because of this right here, guys. What we really want is for could do this either way. We really want dh dt to be the opposite of dx dt. Since dx dt we know is going to be positive, the opposite of that will be negative, and there you go. So that's where I can make this change right here. 2x dx dt is going to equal a negative 2h, and that dh dt can be replaced by a negative dx dt. So where are we now? 2x times dx dt equals, the negative times the negative is positive, and that's a 2h dx dt. Okay, this is a little weird here, guys. This is kind of an abstract problem. And where are we going next? All right, what I think we're going to do now, this is something you might be able to do on your own. We can just divide out the dx dt on both sides. That and that wipe out, that and that wipe out, and now we get 2x has to equal 2h. Oh, and I guess while I was at it, I could have divided the 2's out on each side too. 2 are gone, those 2 and 2 are gone. So then what I really have here is, there we go, x has to equal h. That's really the answer that they're looking for here, guys. They wanted to know, let me read this question again. What is the relation between h and x at the moment when the top and the bottom of the ladder move at the same speed? Well, in order for that all to happen right there, h and x have to be exactly the same distance right here. Let's see, they would both end up being what? The square root of... it'd be 5 divided by root 2, it'd be 5 root 2, never mind, it'd be something ugly right there. But if h and x were exactly the same, meaning if the triangle we were dealing with was isosceles, this would be h, this would be x, that piece would be congruent to that piece, and we'd be dealing with a 45, 45, 90 triangle here with your ladder of 5 meters there, that would mean that at this one moment in time, the base of the ladder is sliding away from the wall at exactly the same speed that the top of the ladder is sliding downward. Kind of makes some sense when you look at it that way. So we were looking for a relation between h and x, and we ended up with a pretty simple one here. They have to be equal to each other for that to happen.